Good morning. All right, last time we did piecewise function, right? So I want to give you the the proper answer for the couple questions we did last time. Okay. When you're asked to graph the piecewise function, right? When you asked to graph the piecewise function, the first one we did yesterday was this one, right? F of x equals to 1 if x is less than, so that was the function f of x equals to 1, 2, 3, right? In a different interval. What we need to be careful about when we are graphing these functions is at the points, at the endpoints of each interval, at the endpoints of each interval, okay? So we know these are different pieces. On the first piece, you can see, yesterday I drew this on the picture, but the picture wasn't that great. So I'm using the software to draw it, but the software doesn't mark the endpoints. Okay, so I want to show you how you mark the endpoints. For example, for example, in this case, right? When we evaluate anything x less than -1, right? So there's 3 cases. So when x is less than -1, according to this function, f of x is going to equals to 1. Okay, but at x equals to -1, f of x is not going to equals to 1. Okay, f of x is equals to what? F of -1. F of -1 equals what? You have to use the second rule. We have to use the second rule. The second rule is 2, right? So how do we express that the first rule does not apply -1, but the second rule apply to -1, right? Do you guys see that? Well, the first rule does not apply when x equals -1, so we use a circle and a dot at this place. You guys see that? Okay. So this tells the reader when the input is -1, when the input is less than -1, right? For this input, you draw the vertical line. Let me make it red. Okay, so for that input, and for the input -1, you draw the vertical line, and the output is 2. Not this one, but it's a one on the dot. Okay, so to express this clearly, okay, we're gonna mark this is circle and the other one is dot. Okay, circle, dot. This is very, very important. Okay, when you do your work in your calculus class, your teacher will be looking for these small details. Okay, these small details. All right, so now let's look at another case. Let's look at another case. At +1, okay, at a +1, you can see the second rule does not apply to +1. Okay, the second rule does not apply to +1. Okay, so let me scroll down just a little bit. Okay, so for the second rule, right? So what we know that when x is between -1 and +1, right? And we know that f of x equals to 2. f of x is equals to 2. That's not a problem. But at f of 2, okay, so we don't need that, but f of 1, f of 1 is equals to 3. F of 1 is equals to 3, right? Because the second rule does not apply to positive 1. It applies to anything less than positive 1. So it doesn't apply to positive 1. So when you evaluate f of 1, you have to go here. Okay, you have to go to the third rule because the third rule covers x larger than or equals to 1. So how do we reflect that on the picture? Similar to what we did. Okay, so as the input is equal to positive 1, if you draw a vertical line, right, your output is on the dot, not on the circle. So these are the details I wish you to pay attention to. So when you draw the picture, and that's what you draw, okay? So the picture without the red line, okay, that's a clear order. So that's the picture you draw. Is that clear? Okay, is that clear? All right, so now, so this is the first example, okay? The second example we did yesterday, okay, at the time, we're close to the end of the class, right? We're close to the end of the class. So this is the final picture. This is the final picture for second example. So we give you the ideas, right? So you draw e to the power x and you draw negative x squared. And then what we do is that we're gonna chop off, right? We're gonna chop off all of these, right? And we're gonna chop off all of that, right? That's what we did. But at the end points, right? At the end point, the end point is 0, right? Which one is a dot, which one is a circle has to be clearly specified, okay? These are the details your professor will be looking for. These are the details your professor will be looking for. For example, for less than or equal to 0 is on e to the power x. Therefore, you must show a dot here, and at the same time, you need to show a circle right there. Okay, so if we chop off everything we need to chop off, right? The final picture we're gonna have will be the one above. Will be this one. You follow me? So this is the, if you ask me, in my calculus class, right? I'm working on this question to graph what picture you should draw. You should present this picture. You should present this picture, not the previous one with all the, all the crossings and stuff. Do you follow me? Because we're talking about do your best work, show your best work. Okay, show our best work. Okay, so don't cross them out like that. This is the answer. This is the answer. I hope that's clear. Is that clear, everybody? Okay, did you guys try number 4 yesterday? Did you guys try number 4? Let me see if there's any answer. Did you guys try number 4? We didn't do number 4 yesterday. Did you do number 4? Did we do number 4? Right? And the other thing is that if I'm asking you, so suppose I give you some questions, right? I'm asking you, hey, give me f of -1, right? You give me the value for, okay, so So maybe I make a table here. Okay, I'm gonna make some tables. So I just give you some random, I'm gonna give you some random questions, right? To see if you understand. To see if you understand these functions. Right, so give me the value for that. Okay, so maybe I should put it over here. I'm just gonna put it here. Okay, so I'm giving you a couple of random questions. Right, you're gonna give me the answer according to the function given and according to the function, say f of 2. Okay, so could you give me those values according to this function that's being defined here? Okay, we'll get to number 4 together. We're gonna do this together. Okay, we're gonna do this together. I want to make sure you draw the graph properly. You draw the graph properly. Actually, we're gonna get to a couple pictures in 50B. 50B. Okay, because those are the curves that you are going to see in the calculus text. Okay, so I want you guys to, we're going to get to a few of them. We're going to get to a few of them. We're not going to get to all of them. Okay. So if you are evaluating f of -1, what do we do? Well, the input is -1. So which category that will be in the category of input equals -1? This one, right? So you're going to get it. You're going to use the first rule, which is an e to the power of -1. Right? 175%. Okay. So can you finish the rest? Piecewise function, right? Different pieces. I still remember when I was teaching calculus 1, some of the students seem to do well, but there are always some students, they don't get that piecewise function concept, despite the fact that I have covered, I cover it in class and review that concept in the class. At the time of reviewing or teaching the class, and I went over, so that's why I find it necessary for us to do something here in pre-calculus, so that you know what to do when you're there. In the unfortunate event, there's not enough time for your other professor to cover these topics more thoroughly. Okay, so what is f of 0? Give me the answer in chat. What's f of 0? One. F of 0. Why is 1? Because 0 is in the first category, right? Very, very good, right? So you're going to use you're going to get e to the power 0. And of course, that's equals to 1, right? 1 is okay. I'm just showing everybody, okay? How about f of 1? How do you evaluate f of 1? What is the value for f of 1? We're going to be using this rule, right? There you go. Very good. Right? It's -1 squared. Very good. The answer is right. How about the second one? F of 2. -2 squared. -4. Perfect. Perfect. Okay, you got it. You got it. Okay, so this is number 2, and that's number 1. Number 1. Do I need to give you some exercise on number 1? Probably not, right? Probably not. So let's look at number 4. Okay, so this function, we have 2 pieces. 1 minus x negative x squared. Oh, I'm sorry, x squared. Okay, if x is less than or equals to -1, and the other one is x is larger than x is larger than -1, right? Okay, so how do we graph this? You graph these, you also have to pay attention to the endpoints. Okay, the endpoints, the circle, dot, and all of that stuff. Okay, so you can put these graph together, right? There are 2 pieces. There are 2 pieces. Right, so you draw the line, and you draw the first one is a line, which is this guy, right? This line. And the other one is x squared, right? But they start from -1. You see, it's a -1, right? And so we have to do some we have to do some touch up. So okay, so that's the picture. That's a picture, right? So this piece is 1 minus x, the other piece is x squared, but x squared is starting from -1. And this line ends at a -1. So at the intersection here, you have to put circle dots in place. You have to put circle dots in place. Okay, so can you guys put those circle dots there? At -1, at -1, what happens? When x is equals to -1, what will be the point? The dot is there, right? The dot is on the line. But how about this piece? Right here. You have to put a circle. This will be considered a complete picture. This will be considered a complete picture. Got it? So now, if I give you some other questions, right? I'm going to ask you some questions. I'm going to ask you to just evaluate. Okay, evaluate. So I'm asking you to evaluate with -2, right? What would that be equal to? F of -1, f of 0, f of, just give you some, I really just choose some random numbers. So that's the graph of the function, right? So give me the answer. What is f of -2?
Three.
That's right, right? It's the first rule we use, right? Because -2 is in this category. So that's going to be 1 minus -2. which is going to be 3. How about f of -1?
2.
Hmm?
2.
2, that's right. Okay, so 1 minus -1. F of 0?
0.
That's right. 0 squared, right? 0 squared is 0. F of 2?
4.
4. Very good. Very good. You see, just two different rules being pieces. These are 2 pieces. Okay. But now if I'm asking you about domain, if I'm asking you domain and range, can you tell me?
Domain would
What's
be
a domain?
all real numbers.
All real numbers. That's right. Every number is covered, right? Every number is covered. Every number can be the input. Negative infinity to positive infinity. And range. Range. If we look at range, we need to look at that, you can see all the real numbers at this level. Above 2, they're covered, right? They're covered. How about at this level, between the circle and 2? And that's also covered, right? Yeah. How about at 0 at this level? How about at this level? Well, the range, what is the range?
0 to infinity.
I'm sorry?
0 to infinity.
Does it include 0? Does it include 0?
No.
It does. You see, we had a 0, right? Andy wrote negative infinity, negative 2u minus 1, infinity. What is, do you mean negative infinity to positive infinity? Or you're answering to the domain? Andy, I'm sorry, I'm not sure I understand your answer. Your answer is for domain and range. What is a negative u minus 1? Oh, the range, I don't know. A union. 2 union. No, the range would not include negative infinity, right? You see, it will, the value will never go beneath 0, right? If you draw a horizontal line, you're never going to touch the curve, right? So you don't get that range. The range is going to be 0 to infinity, 0 to positive infinity. Just from this piece, you can see all the real numbers are covered. Do you see that? All the real numbers are covered from this piece. From 0 to positive infinity. Okay. All right. Thank you for clarifying that. So that's number 4. Do you have any questions? Let's try some other piecewise functions. Okay, so for the first time, we're doing 50b. Okay. The first one, we already did it. It's the same question. Well, slightly different. Actually, the first one is a slightly different question from number 1 on 50a. It's a slightly different question, okay, slightly different. And I want you guys to try that one. Number one. Okay, we start with something simple, okay, and then we randomly choose some questions. And so this is lesson 1. But the second condition says we want the absolute value, okay, because I want to take this opportunity to explain this to you. And the x is larger than. Okay. This notation you may not see very often before under the circumstances. It is really meant that x is between -1, +1. Remember we solved that inequality with absolute value, so that's they're the same thing. They're the same thing. Okay, they're the same thing. When you graph it, this piece it's not difficult to graph, but what I want to show you is that you have to, I need to make some adjustment, okay? I don't know why the software graph it in such an awkward way. Okay, so that's the picture. That's the picture. That's the picture. And this is not a complete. This is not a complete, right? Because we need to mark those endpoints at a -1, at a -1, at +1. We need to mark those points to make it complete. Okay, so in order to answer those questions, we need to answer these, we need to be able to tell these values. For example, at f of -1, what is the value? Right? At f equals to +1, what should be the value? Then you're going to put the circle dot in proper place. Okay, because remember it's definitional function, right? For each input, there should be exactly one output, not two outputs. Okay, so these are the two places we need to tell the reader whether which one is a dot, which one is circle. Do you guys know what I'm talking about? Okay, so now f of -1. What is f of -1? When you evaluate f of -1, which of the 3 rules you're going to use?
2.
That's right. Right, because x equals to -1, it's the second rule. How about +1?
2.
It's also 2, right? So you can see the slight difference from what we did in the one previously, right? There's a slight difference. So on the picture, you're going to have the point -1 input a +2 as dots. Okay, so you have -1, 2 as a dot, 1, 2 as a dot. So you need to have these 2 dots. How about these? How about here? You must put circle there. We must put circle there, okay? So you must put circles over there, okay? So next, we're gonna put circles at -1, 1, and there need to be a circle. Okay, another place, which is 1, 3, and it must be a circle. And that's complete. Are you guys with me? So when you work with these kind of questions, you're given a piecewise function. Your teacher in calc class may ask you to have a picture. Okay, you must have those dots, circles, nicely and clearly done. Got it? I'm speaking from my own experience. As a teacher, I know what I expect from my students. Okay, so that's my expectation. Of course, I would imagine that might be the expectations of most of us. Okay, so is that clear? Let's try something. Let's try something with trigonometry in it. How about that? With some trig functions, right? With some trig functions. Shall we? How about number 9? Do you think number 9 might be of some interest to us? Let's do number 9. Number 9, we have 2 pieces. Okay, so one piece is sine x. The other piece is a cosine x. Okay, less than pi over 4. Right, the other one is x is greater than or equal to pi over 4. And we know the sine curve, cosine curve, so we just draw them. This takes a little more work. It looks like the software is doing the work. You just have 2 pieces, but connected at pi over 4. And then we have to specify circle dot if there's a disconnection. There's a disconnection. Huh, what's going on? So slow. If it doesn't do the work, we'll have to do it, you guys work on it, okay? Work on your paper, okay? Then we do the comparison. Very, very slow. And typically, it's always the endpoints is being questioned. Okay, especially in your calculus class. It's always the endpoints being questioned. They'll be asking you the derivative continuity at pi over 4. They're not going to ask you about elsewhere, because the elsewhere is covered by those theorems. Right? They're continuous, they're differentiable, no problem. Only at the endpoints is questionable. Okay, that's why we're so picky about those circle and dots, right? That's why we're so serious about those circle dots, because answering those questions will make a big difference. Oh, Jesus Christ, what happened? This program doesn't crash. It looks like it's chugging. Well, if it crashes, I have to restart the program. I probably will lose some data. But that's okay. You guys already saw it. You should be able to see the recording. Okay, I'm gonna wait a little bit, okay, until you're done to see if this can be done by that time. No, I think this is hopeless. Close the program. I'm gonna restart that program. I didn't save it. I didn't save it. Oh, wait. I didn't save it. This is too bad, but it's okay. This is pretty bad. Yeah, see, I didn't save it. That's okay. You can view the other stuff on the recording. It won't be not be in the documents here. Okay, so this is f of x. Lesson learned, right? This is the I should save more often. Okay, which I didn't. So this is sine x, cosine x. And over here, when x is less than pi over 4, and the other one would be x is larger than or equal to pi over 4. Did you get your picture already? All right, so let me save it first. Okay. I think this might be too much for this software. I think if the capacity of the software doesn't allow us to do that. I think it's a software problem. I think the software's capacity has a problem. Okay. It's kind of hard to find a software that would do everything for us. And especially in the subject of mathematics. I don't know about other subjects, but so let's open. Okay, we lost some stuff, but that's at least I saved these. Okay, so what we're gonna do is that we're just gonna grab sine, cosine in one picture, okay, and do the crossing, okay, do the crossing. To see if I can. It won't be a perfect picture. I will try to make it better. Okay, so sine x. This is sine x. Okay, and this should include pi over 4, and let's plot a cosine x. And we're gonna make it green. That's a cosine x, okay? And of course you cannot have both the pictures, right? We cannot have both pictures. You have to find pi over 4, right? We have to find pi over 4. So you need to evaluate. Okay, we want to evaluate what is f of pi over 4. Right? At pi over 4, we're going to use a cosine pi over 4. Which is equals to, what do you guys know the value? Yeah? No?
Yeah, radical
2 over 2, right? So at pi over 4, root 2 over 2. It's on cosine curve. It's on cosine curve. Okay. Pi over 4. Right there. Comma. And I make it a green dot. Okay, so that's the place. To the left of pi over 4 is sine x, right? To the left of pi over 4, less than pi over 4, is sine x. So over here, so this picture will be interesting, okay? So let me cross out some pieces. Okay, so these pieces will be crossed out. Don't show that to your professor, okay? And because of technical issues, I cannot make them disappear because that software doesn't work. Do you follow me? So the pieces I cross out, you don't want to show that to your teacher, okay? Erase them completely. Don't cause any confusion, okay? And that's the piece. On the other side, the sine pieces will be crossed out. Do you follow me? So the actual picture you see is this one. Do you guys see that? And there's a dot there. Do we have a circle? The answer is no, we're not going to have a circle because sine pi over 4 is also equals to square root 2 over 2. Okay. So on this one, there's no circle. These actually is perfectly continuous. It's a perfectly continuous function. Okay. No circle, no circle. You just make sure when you graph this, you just make sure you don't show those pieces. Okay, you don't show the pieces that are being crossed out. I cannot do it if that software doesn't work at this point. Okay, I cannot make it because I'm using this platform. I'm using this platform. Okay, so let me try one more time to see if that software will so don't turn something in like this. Okay, if you turn in something like this by me, you're gonna get 0. You have to erase those pieces that doesn't belong. Okay. All right. So I hope I made that clear. So let me try one more time because I do want to give you a perfect answer. Okay, hold on. Please do it for me. I don't know if decimals would do it. I'm not sure. You know what? I'm gonna forget about it. Okay, if I make it work after class, and I'll let you know. Okay, but I hope you understand what I'm saying. Okay. So I need to start this all over again. No problem. Thank you for your patience. Okay, thank you for your patience. So let's choose another one. Let's choose another one. Okay. Open document. Come on. There we go. Well, I did not get to save those other curve either. But anyway, you know what I'm talking about, okay? I will send you a, if I find a perfect, graph, I will send you a picture of it, okay? So the other stuff is lost. Oh, that's okay. Let's try number 8. Okay, number 8. I want to see if this one will work. But this one doesn't have that many. Just have one sine x. Okay. 2 x minus 3. X minus 3 squared. Okay, so if x less than 0, greater than equals to 0, less than 3, x is larger than equals to positive 3. Okay, let's see if it does the work. There, it's I think when there are 2 trig function involved, the software is a little works a little bit hard. Okay, I'll still work on it, and if I get a perfect picture, I'll send it your way. Okay. All right. This is already pretty good because there's some other softwares that it's even more challenging to use these features. Okay, so now we need to put the circles and dots in place. You follow me? We need to put the circles and dots in place. We know that these pieces is sine x to eternity, right? To eternity. But we need to put the circles and dots in place. Okay, so let this be an example. Let this be an example. To put the circle, to put the proper circle and dots in place correctly, we need to answer the following question. One is, what is f of 0? What is f of 3? Right, because these are the 2 connecting points. Okay, so what is f of 0? What is f of 3?
F of 0 would be 2, and then f of 3 is 0.
That's right. F of 0 is 2. F of 3 is what?
0.
0. Very good. Okay, so 0, 2, 3, 0 will be dots. You follow me? So let me just be a little bit more systematic. Okay, let me save it first. Save it first. And insert a row. okay, the dots. So I'm going to put it here on the dots. Okay, so this dot is going to be 0, 2, and the other dot is what? 3, 0. So these are the dots. Okay, so 0, 2 is going to be the dot. Dot. And 3, 0 is going to be a dot. Yeah? Are we good? Okay. Always check back and forth, back and forth. How about these? We have to put a circle there. We must. Okay, we must put circles there. So let's do it. Let's do it. Okay, so let's put the circle, put circles there. What is the circle here? The circle okay, we don't need that. The circles. The circles, where are the circles? The first circle is going to be 0, 0. The second circle is going to be where? 3, 2. You guys see that? Yeah? Okay, so 3, 2, and 0, 0. So then you're going to put those dots in place. Okay, just on your paper. You really don't have to be precise. And that's considered a complete perfect answer. You follow me? If you graph these on the on paper by hand, we don't expect you to do it perfectly. We don't. But we need to see those. We need to see as good as possible, as good as possible. You follow me? And from these pictures, you're gonna tell the continuity and so on and so forth. Okay, you're gonna encounter these questions in chapter 2 of your calculus 1 text course. Okay, is that clear? So we're gonna do one more example, and then we're gonna move on to the next section that I planned. Okay, which is 51A. So how about you guys pick one? Actually, I see number 15. Okay, all of these are from calculus textbook. Okay, all of these are from your calculus textbook. Okay, so if you want to have a head start on this, I think it's going to be good for you. It's going to be good for you. Let's do number 15. Let's do number 15. I need to save the file. Save the file. I don't want to forget it. 15. Number 15, we have a 0 here. And when x equals 0, cosine x. When x is less than 0, 1 minus x squared. You see all these weird functions, right? They will not be weird for you when you're in calculus class, I hope. And I'm sure you're going to be more comfortable with these functions. All right. Save the file. Let's see it. I think this should graph it. All right, good. Thank you. It saved me a lot of trouble for me. Okay, so let's adjust the view. Okay, So that's the picture where, let's see. Yeah. But that's not the complete picture. That's not the complete picture. Okay, this function, if you put the dots and if you put the dots there, it's gonna look really weird. Okay, it's gonna look weird. To know where to put the dots, you have to answer the question. You have to answer these questions. Okay, since the only endpoint, the only problematic point we have here is f of 0. So what is f of 0 equal to?
0.
0, that's right. Okay, so when the input is 0, 0, 0 is a dot, right? So 0, 0 is a dot. Zero, zero is a dot. I'm going to put this over here and the dot. The dot is going to be 0, 0. Okay. And we're also having circles. So let's first put the dots there. 0, 0 is a dot. Then you say, how about this point? Right? Because you can see this cosine x at 0 is 1, cosine x at 0 at 1. This doesn't make a function, right? So this piece, the circle, there needs to be a circle. The circle is right here because at 0, cosine x, that play, we don't use this rule. So there needs to be a circle. The circle is going to be 0, 1 on the curve. So we need to guarantee it's a function. So being a function, meaning that when we have input 0, there's exactly one y value, one output for it. Then that one output for input 0 is the dot, not the circle. Okay, do you see that? So this function is very, 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 very different from other function because the way it's being created. So this function actually has a discontinuity at 0. Okay, you learn that concept, discontinuity, because the way it's defined, okay? I believe the author, I didn't create this question, okay? I did not create this question. I'm just a copycat. This at 0, so it created a discontinuity. Okay, so you're going to see this question in your calculus course. Whether this is going to be your homework, that's a different, whatever. It's up to your teacher. Okay. So let me save that document. Let's take a break. Okay, after we come back, we're going to do basic 51A. But if you see there's any questions in 50B that take your fancy and you want me to go over that, and I will be happy to. Okay, I will be happy to. There are so many questions out there. Okay, so let's take a break. Okay, let's take a break. Come back with your questions. Okay, so I will see you in a little bit. So if you have any questions, please don't hesitate to ask. Okay, otherwise, you will be quizzed on your understanding about piecewise functions in another quiz today, this week. This week you got the first quiz, you're gonna have a second quiz, okay? So next we're gonna cover, of course, I'll quiz you on things I have covered in class. And this one is basics 51A. Okay, because of the difficulties we have with our students, okay, from the experience of teaching calculus textbook, teaching calculus classes, and I feel it might be necessary for us to do these. So for 51, I have 51A and 51B, okay? So I gathered some questions. A lot of those questions are from the calculus textbook. As I mentioned earlier, this function, f of x, equals to absolute value of x. Okay, this rule, okay, this rule function is something that no calculus textbook can avoid. Okay, whether you study, the Math 165, or you study Math 190, or you're taking your calculus classes in any four-year schools, and anywhere you go, and any language you take it. This is the function you cannot avoid. So you have to deal with it. Okay. It typically takes about how many points? It takes about, I would say, 20 points minimum. Okay. It's give and take, giving you or taking away that many points. Okay, this function. And of course, we're very familiar with it. And we even have the narrative of it, right? Now, and we are also familiar with the graph. The question is its variation, how to handle its variation. Okay, you will have to handle its variation. So this is the topics we're gonna go over. Okay, so the title of this section is called Rewrite Functions as Piecewise Functions. Rewrite functions as piecewise. Okay, so it was given like this, but you need to rewrite it as a piecewise function. Why do we need to do that? Because you have two sides, you have two pieces, okay, under different circumstances in your calculus environment, you will have a different expression to use, okay? Continuity on the left, continuity on the right, a limit on left, a limit on right, and there are all kinds of left and right issues. At those points that are usually the end of the interval. Okay, like the examples we've seen earlier, right? At the point like -1, +1, typically those are the points where there's the two curves are connecting. Two curves are connecting. Okay, so this very typical question. Take a simple example, for example, take the first one. I'm sorry, we already did the first one. Let's look at the second one. How do I make, I'm sorry, f of x is x plus 2. How do you make these two pieces? Okay, in this situation, in what we're doing now, we're not worrying about the graphs. The graph is easy. The graph is easy. Any software probably give you a decent graph. We're learning how to handle the algebraic form. The algebraic form. Okay, the algebraic form is where I saw a lot of my calculus students have troubles with. Okay, so this is targeting that kind of problems. So the way we do it, I think I might have done this before, but just in case. Okay, so when we see this function, right, I want you to see it as this. Wait. Okay, as omega. Okay, treat this as omega. Okay, in simple term. So if omega is greater than or equals to 0, or if the omega is less than 0. Do you guys see that? So if you truly understand this expression, okay, these two pieces, and when you deal with x plus 2, it's just x plus 2. So this is x plus 2. Everywhere x plus 2. Do you see that substitution? Okay, that's how you handle it. Did I really get it? Because I want you to see the simplicity of it. Okay, it's pretty straightforward if you get the hang of it. Okay, you view this x not just as a single variable, it's as an entity, as a bologna, as something. It can be very complicated, whatever it is. Okay, and the next step, you just have to write it in a different form. The value you don't have to change, right? And over here, you just solve this inequality. This become x greater than equals to -2. And this will turn into x is less than -2. Okay, at most you would do minus x minus 2, which is not critical. You don't need to change anything here. You just have to solve these two inequalities. You guys follow me? So in the end, what are we getting? Your function is going to look like this. So it's a variation. It's a variation of this form. Is that pretty easy? Yeah, so that's what it is. And then you can graph it, right? You can graph it and do whatever. But once again, the focus is not about graphing. Graphing is settled. We know how to do the graphing, right? It's just shifting of absolute value of x 2 units to the left. That's not something you will find difficult. It's the algebraic form. In your calculus class, you're gonna have to handle when you're taking limit, right? So you have a 2 from to the net when x is approaching -2 from smaller than -2, when x is approaching -2 from larger than -2. So the limit from left versus limit from the right. So those are the issues you will be dealing with. But before you can deal with that, you have to be able to make this happen. Got it? So now let's look at something else. Number 3. Okay. This is another function that you are going to encounter in calculus. Okay. It is the absolute value of x divided by x. In this case, we first need to know the domain. The domain of this function, of course, x cannot be equal to 0. Right? So when we apply that bologna, when we apply that thing, right, you no longer need to consider 0. It's greater than 0. Okay? So when we, and then you're going to divide by x. You see that how that is done in the domain? So as a result, what are we getting? We're getting 1, we're getting -1, and you're done on the algebraic part. Okay, you have your other situation to handle in your calculus class, but at least on the algebraic part, you're done. Okay, so if you graph this function, I'm going to show you the graph of this function. You will see the same graph somewhere in your calculus class. It's an interesting graph. Okay, it's an interesting graph. That's the graph. That's the graph, but not yet, because we have to take out the 0, right? So we're going to have 2 circles. We're going to have 2 circles, okay? Now we're going to have another circle, indicating that this function h is not defined as 0. Okay, that's the picture. Okay? All right. And I want you guys to try one. Okay, your turn. Number 5. How about you try number 5? Just okay. How about you guys try number 5? Well, number 4, number 5. Okay, you do number 5 first and do number 4 second. Okay, your turn. Number 5, number 4. Try it. Okay, if you wish to submit, go for it. Okay, I'm going to give you a couple minutes. I'm not going to make you feel I'm watching you. Okay, just do it. Very nice. Very nice. Let me see the submission. Thank you, Bailey. Very good. Okay. Let's see Bailey's work. Do you guys see that? Okay, so greater than equal to 0 case, less than 0 case, and solving the inequalities. Perfect. Okay, great job. Write it down. That's the same as my answer. Okay, that's the same as my answer. Got it? Okay. So number 5. How about number 4? I'm just going to copy Bailey's work. Okay. Anybody want to take on? Anybody want to take on number 4? Anybody wants to take on number 4? Oh, wow, Bailey again. All right, let's take a look. Got it. Okay, everybody, let's look at this. I would say you're almost there. Remove this piece. Okay, remove those pieces. Okay. And then, yeah, you should get x greater than or equal to 3. So this is not right. These p's is okay. Okay, those are right. Okay, but here it should be x greater than x minus 3 greater than equal to 0 without the denominator. Okay, so this piece is going to be x greater than equals to 3. And that's going to be x less than 3. Okay. All right. So let me put the work together in another place. Okay. So what you do, this is what you do. Okay. We have this guy. Right. So this is our baloney. That's our baloney, right? It represent an entity. So now you have x minus 3, x minus 3, x minus 3, x minus 3. Because the only piece that needed the 2 pieces is the numerator. Okay, but you also have to be aware of the domain. X cannot be equals to 3. Okay, that's the domain. Okay, so now you're going to divide by x minus 3. So the function itself is divided by x minus 3. And this whole thing is divided by x minus 3. And the condition doesn't change. The conditions do not change. Do you follow me? Yeah. So in the end, you are getting this is 1 and this is a -1 and this is larger than equals to 3. And this has to be larger, not equal. Do you guys see that? Less than 3. Because domain has to be considered. You follow me? Okay, the same thing is with number 7, similar. Okay, I'm going to save that for you. So let's look at number 6 and 8. Let's look at number 6 and 8. You guys want to try number 6 and number 8? Your son struggle a little bit. You may get it very well. You may very well get it. And I think you have all the tools. We need to understand only the absolute value piece needs that a conditional statement. The rest of them doesn't need it. Okay. Always be aware of domain first. Everybody is encouraged to submit your answer if you wish. Okay, I would love to see your answer. I would like to, even you can submit answers for the same question. I will all take a look at them. Okay, so try. These are the questions exactly the same as I saw in calculus textbook. Okay, I really did not create any. I was just a copycat. Okay, copy and paste. I copied from the textbook. All right. Let's look at Andy's work. There. All right. X equals to -3. What is that? He factored. That's good. Okay, he did the factoring. Okay, so this expression is the same as that expression. Okay, I don't know what this is for. Okay, and for x minus 2, there are two branches, and I don't know what these symbols are. What are these symbols? And you may like to put if.
I don't think we can't see his work on the screen.
Sorry?
We can't see his work on the screen.
Oh, sorry. My bad. Okay, so I'm grading his work, right? So that equal sign What's this? I don't know. I don't understand that. Okay. The absolute value, we have that part. Not sure what this is about. Okay, I think you should have an if here. If here. I'm sorry, that's in the wrong place. Covered your work. Okay. That's all right, but you didn't complete the question. You didn't complete the question. You pointed out the domain is x not equals to 2. That's good. X equals -3. I'm not sure what that means. But you did it partially. You did it partially. And the factoring part is good. The factoring part is good. Okay, the factoring part is good. But next, we're going to combine these together. We're going to combine these together. Okay, so I'm going to show you how we combine that. Good, very good effort. Very, very good effort. Okay, so let's go back to here. Okay, you did the factoring, which is really good. We will need it. Right, so absolute value of x minus 2, and the top is x minus 2 times x plus 3. Okay, that factor part. You also indicated that x cannot equals to positive 2. Okay, so that's a domain. Okay, so very good. And the other thing you indicated was that the absolute value of x minus 2 is going to be having these two pieces. Okay, which is also very good, right? X minus 2 if x minus 2 is larger than, now because x cannot equal to 2, you just put directly greater than, okay? Negative of x minus 2, and if, okay, x minus 2 is less than 0. You see, when we set this up, we considered the fact that x cannot equal to 2 already, okay? All right, so next, we're gonna have these two, we're gonna work on the G. We're gonna work on the G, okay? The G will have two pieces. Okay, we'll have two pieces, so let's combine them. Okay, let's combine them. Okay, the if will be at the if, okay? And these two conditions will copy and paste, right? Because these are answering to that question, lesson 2. So in this case, right, the absolute, this whole thing, x minus 2, the absolute value of x minus 2 when x is larger than 2 is going to be x minus 2 without the parentheses. And in the other situation, it's going to be the negative of x minus 2. Do you guys see that, how that's been done? Do you see that? You use this absolute value for the denominator part. Denominator has two branches, so you have that two branches set up exactly the same. Okay, and the rest is just reducing it. Okay, x minus 2, x minus 2 reduce, so you have x plus 3. And this one, this next one is a negative of x plus 3. That's it. You see how that's been done? You see that? Yeah? You may like to put this in a proper order. Okay, This will be a better order. Okay, are we good? Number 6. Number 6. Anybody try the number 8? Anybody try the number 8? So first thing we are aware of is X, the domain. X cannot be 0. Right? Everything is operated in the domain. And the absolute value of X right? We have that 2 branches. Right, those ifs. Right? So now let's look at g of x. One of the terms in g of x is going to be involve the absolute value. And it has 2 branches. For that piece, there are 2 branches, right? So we're gonna have that 2 branches, and the conditions are same. Conditions are the same. You guys see that? And next, in this expression, same, but in a greater than 0 case, absolute value of x is the same as x. So this is x. And this piece is negative x. You see, so that's how it works. Do you guys see the process? Did you guys see the process? You want me to do it over? I'm going to do it over. Right? Part of this expression has need a handling of 2 pieces. The rest doesn't need it. So the conditions are going to be the same. Okay, but when you're handling absolute value part, you're going to use that. So you're gonna have these 2 pieces the same, right? For x is positive, absolute value of x is x. So this piece is replaced by x. And that piece is replaced by negative x. Do you guys see that? I deliberately show that process to you. Do you guys see that? Are you watching? Okay. And then we're almost there. We're almost there. The rest is just simplifying. You see, all we do is to try to get rid of the absolute value sign. Do you guys see that? And over here is going to be 4x. 4x divided by x, that's a 4. And over here is 2x. 2x divided by x is a 2. Done. Is that clear? Can you draw that picture? Can you draw this picture? And put a circle dot in place. Put circle dots in place. Just checking on you. Just checking on you. Can you put circle dots in place? You know, these are visual aid. These are visual aid. In the case that you're handling these functions, you want to be able to do it, right? So where are going to be the circles? You're going to have two circles here. Okay, 0, 2, and 0, 4. Okay, so 0, 2 is a circle. 0, 4 is a circle. That's the picture. That's the picture. How did I end up with the 4 and 2? Okay. I'm going to show you here, right? You got to this point, right? You got to this point. 3x plus x is a 4x. 4x divided by x is 4, right? X and x are reduced. 3x minus x is a 2x. And 2x over x is a 2. Yep. You see that? Thank you, Andy. Got it? All right. How do you like that? Is that fun? Is it hard now? Not too difficult. I'm glad to hear that, right? It's just a matter of exposure and practice, right? It's a matter of exposure and practice. And you totally can do it. You totally can do it, okay? So I feel, okay, we have 7 minutes left, and I'm not going to start any new topics. So let's look at 51B. I want you guys to pick 2 questions. I will work with you guys, okay? 2 questions. That's how much time we left. We have 6 minutes. Okay, don't worry about time. I can go over for you, no problem. So all of these questions, I assure you, many of them are from your calculus textbooks. I would say 99.9% are from there. Okay, so let's pick a question. We work together. How about that? The first one, you put that number on chat. I work with you. Number 8. All right, let's do number 8. G of x is equals to 2x minus 1 over 2x raised to the power 3 minus x squared. And all of that is in absolute value. Okay, so we might notice that over here in the denominator, we can factor out the x squared. Can we? We can factor out the x squared. So this will become 2x minus 1. Okay? And then what? Domain, be aware of domain. X cannot be 0, right? And x cannot be what? Cannot be half, right? Right? Cannot be 0, cannot be half. So with all that guaranteed, we're going to operate on the absolute value just a little bit more. Okay, so we're going to take absolute value on this guy. I'm going to take absolute value on the other guy. Because x squared is always positive. Therefore, the absolute value, the x squared, the absolute value on x squared can be dropped. Do you guys see that? Because x squared is always positive in this case. Okay. And next, you can do the conventional way. Okay, we just did, right? You can do it this way, say the absolute value here, and you're gonna have that you know, you have that 3 cases, right? This if, and this is if 2x minus 1 is larger than 0, 2x minus 1 is less than 0, and 2x minus 1 negative of 2x minus 1, right? We should be very familiar with this now, right? And of course, this will change to x is larger than half, right? And this will be changed to x less than half. Are you with me? Okay, so 2 branches. 2 branches. And then what? Then what? We will have that 2 branches. We'll have that 2 branches once again, because the latter expression, right? Because the latter expression. So what we do is that all the conditions stay the same, right? And on this part stay the same. But under this condition, 2x minus, well, x is larger than half. It's just 2x minus 1. So that's just 2x minus 1. You see that? On this next one, it's going to be what? What would this be replaced by? That will be replaced by negative 2x minus 1. You guys see that process? Okay, you can watch over, right? You can watch this over. Now, the next we're gonna wrap it up. Okay, the branches stay the same, 2x minus 1 and 2x minus 1 reduced. So this is gone and this is gone. And this piece, 2x minus 1, take away the 2x minus 1. So this is going to be a negative 1. So negative 1 times x squared, that's going to be a negative x squared. You guys see that? That's the final answer. That's the final answer. Okay. Got it? But since we get to this point, I do want to show you another way to do it though. Okay, I don't want to take too much of your time, but I know the class is over. If you have to go, you can go. Another way I wish to show you. Okay, for G. So what I would do, I would rewrite this as 1 over x squared multiply 2x minus 1, the absolute value of 2x minus 1. We have done something similar about this before, didn't we? Which is number 3, isn't it? Similar. Okay, I want you to see this. Similar to, let me do this. Never mind about number 3, we just do it over, okay? Where's my that? Yeah, I need this. Okay. So I bring this note. This guy, okay, we know that this can be baloney, isn't it? I want you to watch the process, okay? Watch and write down the process. Okay, I'm showing you the process, how these things evolves, how that symbolic operation is done, Well, 0 is not in the domain, so I'm going to remove the 0, right? I'm going to remove the 0. So that one, that is a 2x minus 1, and that's 2x minus 1, and that's 2x. This is very familiar, right? So 2x minus 1, 2x minus 1, right? And we know that's x larger than half, right? Right, that's x larger than half. So I'm going to put it on the same row. X is larger than half. And that is x is smaller than half. So we have that in place. So now the absolute value in the denominator. So if I look at this guy, wait, you know what? I should keep it simple. Never mind. You know what I'm going to do? Go back to the, I'm sorry. Okay, go back. I want to keep it simple. I'm going to give you a simpler version of this, okay? So negative omega is larger than 0. Sorry about that, okay? Even though this way will work, but I'm going to show you a simpler way. Okay, forget this. You see 2x minus 1, the absolute value 2x minus 1. So what I'm going to work on is I'm going to work on the absolute value of omega, absolute value of omega. You guys see that? Now, what does that mean? Well, look at this. Look at that. Okay, conditions stay the same. Conditions stay the same for the denominator. Okay, the denominator has absolute value, right? So this guy will be here as is, right? But when omega is positive, the absolute value of omega, the absolute value positive is the same as the number. The absolute value of a negative is its opposite. Yeah? So this is a positive one, and this is a negative one. Yes? Guess where I'm going to use this for? I'm going to use it for here. I'm going to use this for here. Do you guys see it? Do you guys see it? Okay. So now here, you're going to get two branches, right? Two branches, and your omega is 2x minus 1. 2x minus 1. Do you guys see that? 2x minus 1. Okay, so we're going to have that two branches. Okay. Each piece is going to be like that. Okay, we're going to come back to simplify. The if okay, and what is our omega? You guys see that? Be picky about my work. If you see there's anything you don't understand or any mistake I make, please point it out. Okay, and now when 2x is positive, the absolute value of positive is the same as the positive number. The absolute value of a negative number is its opposite. The absolute value of positive is the same as the number. The absolute value of a negative is its opposite. All right. So last but not least, we finish. We wrap up. Okay. So this is what? This is 1, and this is what? This is negative 1. Right. So you could have put a negative 1, positive 1 over here. You follow me? You could have entirely removed this, applying this directly. Do you follow me? That's what I wanted to show you. And here is going to be x larger than half. And over here is going to be x less than half. Okay, so we use this piece for that. Got it? Well, thank you for your patience. I know some of you had to go and you left. That's okay, but the recording is available for you. And I hope I have shown you the process. Okay, I want you to see that process. If you have to watch it again, feel free to watch it after the recording becomes available. And I will see you guys on Monday. Okay, so we'll put these topics behind us. And your next quiz will have something to do with these. Okay, we'll have something to do with these. Okay. All right, thank you for your attendance. Okay, I'm looking forward to seeing you again on Monday.